In this lesson, we're going to talk about mathematical patterns and sequences. So to begin with, let's define a sequence. A sequence is simply an ordered list of numbers. Example, 1, 3, 4, 7, 11, 18, 29 is a sequence, just simply an ordered list of numbers. Each number in a sequence is a term of the sequence. We can represent a term of a sequence by using a variable with a subscript number to indicate its position in the sequence. For example, a sub 5 is the fifth term in the sequence a sub 1, a sub 2, a sub 3, a sub 4. The subscripts of sequence terms are often positive integers starting with 1. So again, the subscript, like the 5 right here that you see, that simply means the fifth term. Which means we can generalize a term such as a sub n as the nth term in the sequence. N can be any number we want. If n's 100, then we're looking at the 100th term. If n is 50, it's the 50th term. If n is 6, it's the 6th term. Explicit formulas. Sometimes we like to define our sequences by an explicit formula. It describes the nth term of the sequence by using the number n, the term that we're after. For example, take a look at this sequence 1, 4, 7, 10, 13. Notice that every term goes up by 3. Therefore, the nth term is 3 times the value of n minus 2. So as you can see, if we let n be 2, it would be 3 times 2, 6, minus 2, 4. If we look for the fourth term, 3 times 4 is 12, minus 2, 10. We would write this formula as a sub n equals 3n minus 2. And then we can plug in whatever we want for n. We can plug in 5, we can plug in 10, we can plug in 6. We use explicit formulas to help us generate terms of a sequence. Take a look at this example. Find the first 6 terms of a sequence. In our first term, our explicit formula is negative 5 times n plus 1. Well, we would simply plug in the numbers 1 through 6 for n and evaluate. A sub 1, the first term would be negative 5 times 1 plus 1, which is negative 5 plus 1, or negative 4. The second term, negative 5 times 2 plus 1, negative 10 plus 1, negative 9. Third term, negative 5 times 3 plus 1, negative 15 plus 1, negative 14. You can kind of catch the pattern here. The fourth term we plug in 4, the fifth term we plug in 5, and finally the sixth term we plug in 6. Now, something we'll talk about in a later lesson. Notice that our terms are decreasing by 5 every time, and notice that our explicit formula is multiplying by negative 5. That will be important coming up. A nice way for us to generate a lot of terms of a sequence in a big hurry is to use a spreadsheet, like Google Sheets or Excel. Well, let's take a look. A sub n equals 2 to the nth power minus 1. We're going to check out this link, 2 to the n minus 1, and we're going to go to a Google spreadsheet. So let me clear a few things off my sheet here. There we go. Delete. Sorry guys, computer's running a little slow tonight here. Okay. So, in column A, I title when we talk about a spreadsheet, we talk about it in terms of columns and in terms of rows. Columns go by letters. Rows go by numbers. And we talk about cells in a spreadsheet, and we identify a cell by its column letter and its row number. So right now in cell A sub A1, I write term number, and I literally write out term number. And if you look right here at the bar right above the A, B, C, D, E, F, the columns, this is what you're typing into. So in A1, I write term number. In B1, I write term value. Well, remember what we said by the definition of a sequence. It's a list of terms, most often starting with 1. So I'm just going to put 1 into cell A2. Now, in cell A1 or B1, I'm going to figure it out. Now, with a spreadsheet like this Google Sheets or like Excel, when I want to do a formula, I type in an equals. So I put in an equals first. This tells the sheet that it's about to do a calculation. What I'm going to do, well, remember our formula was 2 to the n minus 1. So it's 2 raised. Now, where is the n's at? Well, the n's are back here in column A. So A sub 1 minus 1. Oh, screwed up. So let's go fix this. Instead of A sub 1, I want A sub 2 minus 1. Bam. My Google Sheet just figured out my first term. And you're probably out there thinking, well, gee, Mr. Giesing, I could have done that pretty quickly in my head. And you can. Well, here's where the benefit's going to come in. Notice in column A3, cell A3, again, I'm going to put in an equal sign. Now, when you do the terms of a sequence, you start with positive integers starting with 1 and consecutive positive integers. So I'm going to go A2 plus 1. And this is just going to quickly generate me my n's. Now, here's the nice thing with the sheet. Up here, I want to copy this, but I don't want to have to do it all over again. So I go over here to this box in the bottom right-hand corner, and I just grab it and I pull down. And notice when I click on the formula, if you look at the bar above it, it doesn't say 2 times A2 minus 1 anymore. It says 2 times A3 minus 1. Because what I'm doing is I'm filling this column. Now here's a nice thing I can do. I can grab both these rows. I can grab cell A3 and B3. That's put my box in the right-hand corner. And then I can just drag and pull it on down. And I've quickly generated 24 terms in my sequence. Pretty cool. So instead of me having to sit there and crank it out, 2 times 2 is 4, minus 1 is 3. 2 to the third is 8, minus 1 is 7. 2 to the fourth, 16, minus 1 is 15. I got 24 terms. Bam, just like that. Oops. Let me back up. Sorry, I got a little trip happy. Remember, in a spreadsheet, when you type in equals, the sheet knows it's about to do a calculation. And again, you can then go down and just pull, and it fills up that entire column, and it automatically updates the cells going down as you wish. Another type of formula for a sequence is called a recursive formula. Because sometimes we can see a pattern in a sequence by comparing each term to the one that came before it. Remember the first one we had? The 1, the 4, the 7, the 10, the 13. We said we're going up by 3 every time. Take a look at this example. 133, 130, 127, 124. You may see a pattern. Yeah, we're going down by 3 every time. Each term after the first term is equal to 3 less than the previous term. So instead of writing out this explicit definition, we can write it out as a recursive. And a recursive definition contains 2 parts. An initial condition, the value of the first term. We got to know where to start at. Well, we know that the first term of the sequence is going to be 133. Always that's going to be given to us. A recursive formula relates each term after the first term to the one before it. Get me out of the way here. So, for our sequence of 133, 130, 127, 124, the nth term is the term before it minus 3 for all n's greater than 1. Now, in that recursive formula, the a sub n minus 1 simply means the previous term. So if I'm looking for the 8th term, I use the 7th. If I'm using for the 20th term, I use the 19th. I use the term previous to the one before it. Let's look at an example on betting. Let's write a recursive definition. 4, 8, 16, 32, 64. First thing, find the pattern. You're right. We're going up by 2. We're multiplying by 2 every time. So again, we need 2 parts to this. 2. I said 2. 2. We need to set the initial value, in our case 4. Then we need to set a recursive formula. And the formula is very simple. It's whatever the pattern is. So what's our pattern? It's 2 times the previous term. Done. Look at a second example. Here's that 1, 4, 7, 10, 13 that we had earlier. Again, what's the pattern? Yeah, we're going up by 3 every time. So we set our initial value, which I messed up because our initial value in this case should be a 1. The recursive formula tells me how to find the next term given the previous term. Add 3 to the previous term. So the nth term is the n minus 1, the previous term, to it, plus 3. Recursive. As we finish up today, let's write a recursive definition for this sequence. 1, 3, 4, 7, 11, 18, 29. What's the pattern? Well, we can set our initial conditions. In this case, it's conditions because we're going to set the first 2 terms. You guys figured out what we're doing yet? Well, if you don't see it, every term is the sum of the 2 terms before it. 1 and 3, 4. 3 and 4, 7. 4 and 7, 11. 7 and 11, 18. 11 and 18, 29. So in this case, we're going to set our initial condition, and we set it for 2 terms, not just 1. Our recursive formula, the nth term is the sum of the 2 terms previous to it. So n minus 1 would be the term right before the nth term, n minus 2 would be the term previous to that. Final thing in this lesson is determining formulas. Determine whether each formula is explicit or recursive. Then we'll find the first 5 terms. A sub n equals 2 times a sub n minus 1 plus 3, where a sub 1 is 3. Well, in this case, notice that the nth term is defined by the term previous to it. That makes it a recursive sequence. And here's the first 5 terms. Notice they give us the first one, 3. Then to find the next term, we take 2 times the previous term plus 3. So the first term is 3. 2 times 3 plus 3, 9. 2 times 9 plus 3, 21. 2 times 21, that's 42, plus 3 more is 45. 2 times 45 is 90, plus 3 more is 93. Example 2, notice that we're defining n, the nth term, by the value of n itself. That makes it an explicit. In example 1, we define n by a term previous to it. That makes it recursive. This is an explicit. The nth term is 1/2 times the term number times 1. So in our case, for the first term, it would be 1 times 1 minus 1. That's 0. 2 times 2 minus 1, half of that, 1. 3 times 3 minus 1, 3 times 2 is 6, half of that is 3. 4 times 3 is 12, half of that is 6. 5 times 4, 20, half of that is 10. And that is our first lesson of Chapter 9 on mathematical patterns and sequences.